This is the supplementary video for the experiment on molar mass determination by depression of the freezing point. When you have set up all the glasswares and equipment you'll be using, make sure that the digital thermometer does not touch the bottom of the calorimeter. If it does, use a rubber stopper to prop it up. Now it's time to prepare your ice-water mixture in your calorimeter. From the reagent cart, open the ice bucket and fill up your calorimeter cup 3/4 way up with ice. Now back at your workbench, measure 20 ml of distilled water from your 100 ml graduated cylinder. Make sure to measure the volume at eye level and always measure at the lower meniscus. Now decant the distilled water into the calorimeter cup. Replace the lid immediately with a digital thermometer inserted. Stir the mixture and record the lowest temperature reached by the mixture. The temperature may not be 0 degrees centigrade. Record the lowest temperature attained by the ice mixture. Weigh the calorimeter cup and the ice-water mixture only. Do not include the lid and the thermometer. Record the mass. Then add slowly 10 grams of your unknown liquid using a stirring rod to direct the liquid into the middle of the cup. This technique will prevent the liquid from spilling at the side of the test tube. Now record the mass of the calorimeter cup containing the liquid unknown. Now put the lid back. Pre-weigh your 250 ml beaker and record its mass. On your workbench, stir the mixture until you record the lowest temperature reached by the mixture. You should obtain a freezing point depression of at least 4 degrees centigrade. Into the pre-weighed 250 ml beaker, pour the mixture of ice, water, and liquid sample from the calorimeter cup through a wire strainer to separate the solution from the ice. Pour back the ice from the strainer to the calorimeter cup. Record the mass of the beaker and the solution for your first trial. For your second trial, pour the solution back into the calorimeter. Do not add more unknown liquid. However, add more ice. Replace the lid and stir the mixture. Record the lowest temperature reached by the mixture. Remove the lid and again separate the solution from the ice by pouring the mixture through a wire strainer into the empty 250 ml beaker. Put the ice back into the calorimeter cup and discard this in the sink later. Record the mass of the beaker and the solution for your second trial. When done, dispose the liquid solution into the labeled hazardous waste container in the fume hood. Slowly decant the solution into the labeled liquid unknown hazardous waste container. Put the lid back and slide the hood doors to close. Now it's time to do your solid unknown. Pre-weigh your 250 ml beaker and record the mass. Weigh around 10 grams of the unknown solid into the beaker. Record the mass. Repeat finding the freezing point of ice-water mixture. Record the lowest temperature attained by this. Measure 20 ml of distilled water and add into the 250 ml beaker containing the unknown solid. If solid doesn't dissolve completely, add 1 ml increment of water until it dissolves. When all the solids have dissolved, add the entire solution of the unknown solid into the calorimeter cup containing the ice-water mixture. Immediately replace the lid and stir the mixture. Record the lowest temperature attained by the mixture. Separate the solution from the ice by decanting the mixture through a wire strainer into the 250 ml beaker. Pour back the ice from the strainer into the cup. Record the mass of the beaker and the solution of your first trial. Now continue with your second trial. Decant the solution back into the calorimeter cup and add more ice. Immediately replace the lid and stir the mixture. Record the lowest temperature attained by the mixture. Remove the lid. Separate the solution from the ice by pouring the mixture through a wire strainer into the empty 250 ml beaker. Record the mass of your solution for your second trial. Pour back the ice into the cup and discard it in the sink. Discard the solution into the labeled waste bottle inside the hood.